Imagine you're miles away from the nearest town. You're hiking a remote trail, or maybe you're driving through a foreign country where your data roaming just stopped working. You reach for your phone, but the screen stays black. No signal, no GPS, no blue dot to tell you where you are or which way is north. In that moment, the world feels much larger and much more dangerous. For most people, this is the start of a panic-driven disaster, but for those who know how to read the language of the earth, it's just another Tuesday. Today, we are going back to basics. We are mastering the lost art of land navigation. We're going to learn how to read topographic maps, how to use a compass like a pro, and how to use the stars and the sun to find your way home when technology fails you. Let's get oriented. Before you can move, you need to understand your map. A topographic map is a 3D world flattened onto a 2D piece of paper. The most important things to look for are the contour lines. These are the brown, wavy lines that cover the map. Each line represents a specific elevation. If the lines are far apart, the terrain is flat or a gentle slope. If the lines are packed tightly together, you're looking at a steep cliff or a mountain. If you see a series of small concentric circles, you found a peak. Understanding these lines allows you to see the mountain before you even get to it. You also need to check the scale. If the scale says 1 to 50,000, it means 1 inch on the map equals 50,000 inches in the real world. Without understanding scale, you can't estimate how long it will take to reach your destination. Always look at the legend, the dictionary of the map, to identify rivers, roads, and different types of vegetation. Now, let's introduce your best friend, the base plate compass. A compass doesn't just point north, it acts as a bridge between your map and the physical world. To use it correctly, you first need to understand the difference between true north and magnetic north. Your map is aligned to the North Pole, true north, but your compass needle is pulled by the Earth's magnetic field, magnetic north. The difference between these two is called declination. Most maps will have a small diagram at the bottom telling you the declination for that specific area. If you don't adjust for this, a 10-mile hike could lead you miles away from your target. Once adjusted, you can perform a map orientation. Lay your compass on the map, rotate the map until the north-south lines on the paper match the needle on your compass. Now, the map in your hand is perfectly aligned with the ground under your feet. But what if you don't know exactly where you are on that map? This is where triangulation comes in. This is the ultimate survival skill. Look around and identify 2 or 3 distant landmarks that you can also see on the map, maybe a specific mountain peak, a lake, or a bridge. Using your compass, take a bearing, a degree reading, on the first landmark. Draw a line on your map from that landmark along that bearing. Now do the same for the second landmark. Where those 2 lines intersect on your map is exactly where you are standing. It's like a physical version of a GPS ping, and it never runs out of battery. Navigating isn't just about looking down at a compass, it's about looking up at the world. Dead reckoning is the process of calculating your position by using a previously determined position and advancing that position based upon known or estimated speeds over a given time and course. In simpler terms, if you know you walk at 3 miles per hour and you've been walking north for 2 hours, you should be 6 miles north of your starting point. To make this accurate, professional navigators use pace counting. Use a set of pace beads or keep small pebbles in your pocket. Every time your left foot hits the ground 60 to 65 times, which is roughly 100 meters for most people, you move 1 bead. This way, you always know exactly how much ground you've covered, even in total darkness or thick fog. What happens if you lose your compass? Nature has provided us with signs that never lie. The most famous is the sun. The sun rises in the east and sets in the west, mostly, but you can be more precise. Use the shadow tip method. Drive a stick into the ground and mark the tip of its shadow with a stone. Wait 15 minutes and mark the new position of the shadow's tip. Draw a line between the 2 stones. That line is your east-west axis.
The first stone is always west and the second is east. Now you have a compass drawn on the dirt. If it's nighttime, look for the North Star in the northern hemisphere. Find the Big Dipper, follow the two stars at the end of its cup in a straight line, and they will point directly to Polaris. Polaris is the only star that stays still while the rest of the sky rotates. If you can see it, you can never be lost. In the southern hemisphere, you look for the Southern Cross. Since there is no South Star, you follow the long axis of the cross and imagine a point about 4.5 times its length down towards the horizon. That point is south. Even the trees can tell you a story. In the northern hemisphere, moss tends to grow more heavily on the north side of trees because it's the shadiest and dampest side. While this isn't 100% reliable as a primary navigation tool, it's a great sanity check to confirm your other readings. One of the biggest mistakes people make when navigating without GPS is target deviation. If you are aiming for a small cabin in the woods that is 5 miles away and you are off by just 1 or 2 degrees, you will walk right past it and never see it. To avoid this, use a technique called aiming off. Instead of aiming directly for the cabin, aim for a handrail, a long, unavoidable feature like a river or a road that is to the left or right of the cabin. If you aim for the road, you know that when you hit it, you just have to turn left to find your destination. This eliminates the guesswork and ensures you don't go wandering into the deep woods. Finally, we have to talk about the mental map. Your brain is a powerful tool, but it is easily tricked by stress. When we get lost, we tend to walk in circles. This happens because one of our legs is usually slightly stronger than the other, causing us to lean into a curve. To stay in a straight line without a compass, use intermediate targets. Don't just look at the horizon. Pick a specific, unique tree or rock about 100 yards ahead of you. Walk to it. Once you reach it, pick another one. By leapfrogging from one point to another, you force yourself to maintain a straight course. Navigating is more than just a skill. It's a change in perspective. When you use GPS, you are a passive observer, a passenger in your own life. When you use a map and a compass, you are an active participant. You notice the dip in the valley, the way the wind hits the ridge, and the position of the stars. You become connected to the landscape. If your GPS fails, don't panic. Sit down, take a breath, and remember that for thousands of years, humans navigated the entire globe with nothing but the sun, the stars, and their own intuition. You are a part of that lineage. Keep a paper map of your local area in your car. Buy a decent compass and practice with it in your local park. The best time to learn how to navigate is when you're not lost. Preparation is the bridge between an emergency and an adventure. Stay sharp, keep your eyes on the horizon, and remember, you are only lost if you don't know how to find yourself.